Alright class, we're going to build two circuits from the PLTW notes, and one on the bottom here is a series circuit. So you have three resistors hooked up end to end, and then I have a multimeter in the circuit itself, so the current has to go through the multimeter in order for it to take a reading. So we got 6.35 milliamps. That's going to be consistent throughout, no matter where you take that reading in a series circuit. If you come up to the top, that's a parallel circuit. If you put the milliamp, or if you put the multimeter in those three locations, you're going to get different readings because the current is either faster or slower depending on the values of the resistors. So current does act differently in a parallel circuit than a series, and let's take a look at how we built this in Tinkercad, and then take a look at the or compare that to the notes of what they were going for in the examples in the PLTW PowerPoint presentation. So let's take this off and put up the this is the notes from the PLTW website, and let's go. Here we go. All right. So I'm going to shrink this one down here a little bit just to get out of the way. All right, we can see the values still. So we got first resistor is 220 ohms, second one's 470 ohms, and the third one is 1.2 kilo ohms or 1200 ohms. So we're going to put that over there. We're also going to bring up, let's bring this up, let's shrink this down so we can take a look at it. Alright, so we can kind of compare what we're doing here. Alright. Okay, so we are building the first series circuit. So we got our values are going to be 220 ohms, 470 ohms, and 1.2 kilo ohms. Remember, you have to change the drop down from ohms to kilo ohms depending on where, what the values ask for. All right, so we're just simply hooking up a simple series circuit with three resistors. There's no LEDs or any motors or anything like that. It's just a simple series circuit. All right, so that third resistor is a 1.2 kilo ohm. So we had to change the drop-down menu from actually the default is kilo ohms. So just make sure that you double check to make sure you're in the proper ohms kilo ohms measurement. Okay. All right, so we're hooking up our first wire going into the positive. Then we're going to hook up the first to second resistor, and we're going to, and it doesn't matter which direction the electricity flows. Unlike a LED where it has to go through one way, a resistor can, you can swap it around and it's still going to work. Alright, so just like the bottom picture at the bottom, down there by the alligator, you see, let me see if I can use the alligator to point out what I'm doing here. I don't know if that's going to work. Where is the alligator? There it is. Move this guy up to the top. Alright. So we are building this guy right here. Alright. So putting that multimeter in there, that's got to go into the circuit itself. So we're just making sure the red wire is going into the red, black's feeding into the number 2 resistor. Okay. And you'll notice that the first resistor has 2 red wires going into it. And why is this? Well, the multimeter has a directional requirement for that current to go through there one way. So you have to put the red wire coming from the primary direction of the current, which is the first resistor. So now what we're doing is, to check the resistance, you do have to take the power off the circuit. So as you notice, I took the power off the circuit, pressed, I'll press start here. Move the wires over, and then I'll press start, and it'll make the prototype live. And 470 ohms, that's exactly what the setting was on the resistor, 470 ohms. And so that's kind of neat how that works. All right, so just to simply get used to how the multimeter works, it's a good idea to do all the resistors and just get an idea. Because when you use an actual multimeter, if you don't watch what you're doing, like switch it over to ohms when you have power going into the circuit, you could damage your multimeter, which in this case, this particular multimeter is maybe $10, but the other ones can run you anywhere from $50 to $100. So you want to make sure you know what you're doing before you run a perfectly good multimeter. All right, so got that one done. Now we're going to work on this up here, the second one. This is a parallel circuit. As you can see, the power is going in independently. Each one of these has independent access to the power. So no matter which one is out or which one's good or not, they're all going to work. Or the remaining ones will work if one's out. So with a parallel circuit, I'm checking for current, and you can see that I'm going to plug in the multimeter after each resistor to see what the current is after that resistor. And the current's going to drop depending on the value of the resistor. I got, I think, 3 different values. One's pretty high, so your current's going to be affected by the resistors, obviously. And that's the main difference between a parallel and series circuit is your current in the series is going to be here, here, or here. It's all going to be the same current. Unlike here, you're going to have different current readings depending on where your values are on the resistors. So, all right, so we're going to hook up this, and this is how we built it. And one thing you're going to run into is that if you do these projects with a lab partner and you're using the lab partner's Tinkercad account, all of those completed projects are going to be in your lab partner's Tinkercad account. Why not, when you guys are done, go in and build this, replicate it in your account as well. And I think you can actually share this. So you click on the share button, which is up here somewhere, and you can share that with your lab partner. Your lab partner imports it into their account, and so you worked on it together, you don't want to have to recreate it. I've never actually shared my projects with anyone else. I'm not sure how it looks on the other end, but in theory, you should be able to share this with your lab partner, and they can import it, because I know I can import 3D AutoCAD stuff into Tinkercad, so it would make sense that you could import these electronic projects as well. All right, so I've got the parallel circuit all set up, and it matches up with, oh, did I forgot to put in, take that off and put, yeah, I forgot to put the parallel circuit PowerPoint up. All right, so that's what we're creating. So now to find the total resistance, it is a challenge. If you've never done this before, I highly recommend doing this with a scientific calculator, because finding the common denominator is going to be a monumental feat without a scientific calculator. So as you can see, we're finding the reciprocal of the reciprocal, the sum of the reciprocal of the reciprocal. So all this over here has to be done with a financial or scientific calculator. I've done it before with that one, and it was a massive headache. We got way off track from physics and electronics, and we spent a day or 2 days trying to find the common denominator of some ridiculously high number. It was like 3,552 on one denominator and 57 on the other. It was crazy. It took us a long time. So yeah, get a nice calculator. If you don't want to pay $100 for the calculator, I would highly recommend go on eBay. You can get them for like $20 on eBay. They'll show up in a couple days. You're still saving about $50-$60, and there's always college students out on eBay trying to sell their stuff after they graduate. Never pay full price for a calculator. All right, so, or you can actually download them on your iPhone or Samsung nowadays for like $2. But that's not quite the same. They don't have the same look and feel as a regular calculator. All right, so resistance total is 346. I missed it. I got this bottom PowerPoint on a continuous loop, so we'll see that come back in. So we're the current total is going to be voltage total, which is 15 volts, divided by 470 ohms, which is our rounded up value for our total resistance. So the current total is 32 milliamps, and I think I have a multimeter that shows we have 32 milliamps on there. So here's current 1, current 2, current 3 on resistor 1, 2, and 3. So those add up. Those are going to add up to be your total current. Let's see. Hopefully I got that right, or I'm explaining this correctly. Let's see if that's what my multimeter on the top shows. 31.9 milliamps. It's going to cycle through. This is my current total. There's 31.9 milliamps right there. Okay. And let's see what I got. Oh, there's my 31.9 milliamps. So I've got my pictures I'm showing over here. The just a snapshot of that resistor right there. So let me blow this up here, get this out of the way. So you know how to build it in Tinkercad. It's following these schematics is not that difficult. It does get difficult once you start layering on multiple functions like motors and horns and buzzers and sensors. But as long as you understand the basics of how to read a schematic, then building these more complex things in Tinkercad and then eventually in the lab, it'll just make sense, and practice makes perfect. So the toughest part is that formula, the reciprocal of the reciprocal. That is something that you have to practice. After about a week and a half, most of my students got it. They didn't have any problems with it. In the next lesson, we're going to talk about a combination circuits where you have half of the schematic is series and the other half is parallel. That's when it gets a little bit more complex, and you have to learn how to combine those values, and there's a process for that. So total resistance is, let's see how long it takes for it to plug in there. Alright, so reciprocal resistor 1 is 470, 2 is 2.2 kiloohms, 3 is 3.3 kiloohms. Remember in your calculator to put in your parentheses or you're going to get some weird number. So 346.5, they round up to 350 ohms for your total resistance. And voltage across this component is voltage total equals V1 equals V2 equals V3. So it's the same all the way through. Current through each resistor is going to be a little bit different. So current for 1 is going to be 15 volts divided by 470. That's your first one. And that's 32 milliamps. Current for 2 is going to be 15 divided by 2.2, which is 6.8. 3 is 15 divided by 3.3, which is 4.5. And then your current total is 43 milliamps. And just looking at the picture up there to see if it has the same thing. Yeah, so to double check your math, when you build this in Tinkercad, hook up a multimeter and check each one to make sure it matches up, because there's been some times where I've copy and pasted resistors into there and put them in the wrong place. Had to go through the entire circuit to figure out what it was, and I may have had that mistake on a circuit that I had, 50 LEDs and 10 resistors, and it's hard to track down each one. In a real circuit, you're going to have those spot checker multimeters where you can go and just touch the resistor or touch the LED, and it tells you if it works. If it's not lit up, then it's in the wrong way. Different things that you kind of learn. And so next tutorial, we're going to do a combination circuit, which is going to be a series and parallel circuit. So that sums up this, and I'll see you in the next tutorial.